In today's lab activity, layering hot and cold water, we looked to see the correlation between temperature and the density of materials. So here we are. We started with some room temperature water, and I just left this water. It's normal clear color. I also have some red tinted hot water and some blue tinted cold water. Now the food coloring does have the same density of water, so that is not going to affect either of the materials. The materials do not have salt in them, so the only variable we are testing is the temperature. Alright, so what I'd like you to do first, if you've not already done so, is go ahead and write down your prediction as to what you think will happen. Alright, once you've written your prediction, we're going to go ahead and do the experiment. So first I'm going to insert our cold water, and as I put the cold water in, you can see that the cold water sinks to the bottom of the container and therefore is more dense than the room temperature water. Alright, so next let's see what happens when we put in the hot water. So as I put in the hot water, you can see that it is floating back up towards the surface of the hot water, indicating that hot water is less dense than cold water. So we're going to let that settle out. Okay, so now that we have all three liquids in our container, you can see the blue cold water on the bottom, the clear room temperature in the middle, and the warm red water on top. So you're going to go ahead on your lab sheet and indicate which is the most dense and which is the least dense. And we are going to go ahead and let this sit for a couple minutes. And after about 5 minutes, we are going to see what has happened to our vial. We're going to talk about the energy transferring going on and the difference between hot and cold materials. Okay, now that we've let about 5 minutes or a little bit more pass by, you can see what has happened to our coloring. So as the warm water, because it had more energy, and it was in direct contact with the room temperature water, it released or conducted its energy from the warm water to the room temperature water. And then as that energy conducted through and the warm water cooled off, the warm water became cooler and began to sink. Now, as that energy has been conducted down through the room temperature water, it's now being conducted down to the cooler water. So the cooler water is now going to gain more energy, and as that warms up, it is going to start to rise. So if we would let this sit, say, overnight, eventually they would become the same temperature, and essentially if they are the same temperature, the warm room temperature and cool water should all mix together to form one consistent fluid. Alright, so let's review what we learned from this lab activity. So we know cold water is more dense than room temperature water, and hot water is less dense than room temperature water. So hot water is the least dense, room temperature in the middle, and cold water is the most dense. So let's talk about why that is. So as objects gain energy, or if they have more heat, the molecules are going to move around a lot faster, and therefore they're going to spread apart, making them less dense. However, cooler materials, the molecules have less energy, so they're moving more slowly, and the molecules are going to be closer together, making them be more dense. So this is how temperature affects the density of materials.